So what if not all these counts are given? So for example, you could have a final entry in your table that is denoted with K plus, which means outcomes equal to K or larger. And you could have a corresponding number NK plus that comes with it, right? So we often ignore that. We often say, okay, let's pretend as if the final entry is just this final K with a corresponding number NK. But if you want to do it in a more correct way, then you could say, well, in fact, you've got a kind of censoring there, right? So the final entry in the table is number of claims observed. On this particular number of claims observed is K or larger than K. So what the contribution to the likelihood should be is the probability then to observe K or more than K claims according to your assumed distribution. And that contribution to the likelihood can then be written like this. So it's the sum of pk plus 1, and so on and so forth, to the power nk, or it should be to the power nk plus, sorry, that's a typo. This should be to the power nk plus, right? The number of times we see that kind of outcome. And then, of course, you know that this probability to observe k claims or more than k claims, that is equal to 1 minus the probability to observe less than k claims, right? So this would then be our final contribution to the likelihood if we do it in a very correct and a very solid way, right? So that's one extra comment. So if you would see something like this as the table, so you look at the number of claims per day. I don't know the exact story here behind this example, and you look at the observed number of days with that particular number of claims, then you'll see here that you have an entry in the table that you do not want to ignore. So you explicitly want to build in that the final entry in your table would be observing 6 or more claims under the probability model that you assume, and you observe that particular outcome 9 times in your sample. So if you write down the likelihood, you'll get something like this. So you see 0 claims 47 times in your sample. You see 1 claim, an outcome of 1 claim. You see that 97 times in your sample, and so on. And then this final entry is the probability to observe 6 claims or more. And that's something you see 9 times in your likelihood, right? In your sample, sorry. So the full likelihood should be written like this, to be precise. And then, of course, you can plug in the probability function that you are assuming. You can take the derivative, either analytically or numerically, and you can optimize this likelihood over the unknown parameters in your probability model.